All right. Thank you for coming. So today we're going to do 2.1 area between curves. So we did that before. We had the curve, and then we do integrate. Then we want to find the area under the curve, right? But then what if we have two curves? How do you find the area between two curves, right? So we said that this is one curve and we said that this is another curve. So we want to find area between those. So it's like that, okay? Now we have the definition. Then let me write down the theorem. 2.1, finding the area between two curves. Okay, we know that the function must be continuous, right? And I want to write down this one, f of x, this condition, right? Then an interval, let me just make it shorter, on between A and B. Then we want to find the area, integrate from the A to B, the region here, right? Then we do absolute value of f of x minus g of x. And then we have an absolute value of dx, okay? All right. I'm gonna check your question later on in the chat, okay? Because I can answer right now and then I cannot type. Thank you for your patience. All right, so your book is really nice because your book has absolute value. That means it doesn't matter. We subtract from top minus bottom or bottom minus top, right? So we get, oh no, we have to have, yeah, you have the condition f of x is greater than g of x. Yeah. They just cover, just not negative. Okay. All right, then look, this means top curve minus bottom curve. Okay, let us do this problem. We have function. Then we have a reason. Bounded above by the graph or function. Let me say the function. F of x equal to x plus 4 and below by the function g of x equal to 3 minus x over 2 in 1 and 4. Find the area of region R. Okay, so it's a matter we draw, but then there is a clue in the statement. They say that bounded above by, right? So above by this function and below by this function, right? Then we notice that which one is the top, which one is the bottom, right? So this is the must be top. This is the bottom, right? because they say so, bounded above by and bounded below the by. Okay, all right. Let me draw. So we have so 4 like this, and then like that. So this is f of x. Let me just write down g of x. Okay. All right. Now we want to find out the area. So they already give us the interval. So we're gonna set it up. Look, top minus bottom curve. So we will have from 1 to 4, top, which is x plus 4. Say better. And minus 3 minus x over 2. Okay, that's the bottom curve, which is g over x. Now, dx. Let us simplify before we integrate. So x, we have x and x. Okay, how about the constant 4 minus 3?
Just 1.
Just 1, so we have 1. 1. And look, we have x minus x minus x over 2, right? So what do you get this one?
3x.
Good. We have 3x over 2, right? Now we want to integrate. So what do you get? We integrate over 1.
X.
X, good. And we integrate 3 over 2x.
3 over 4s squared.
X to the second power over 2, so 3 over 4. Very good. Now we're gonna evaluate from 1 to 4. So we have 4 plus, now your turn. Can you please calculate this one? 1 plus 3 over 4.
It was 16 minus
15 minus 16 minus, good.
15 minus 7 over 4.
Thank you so much.
And it will be 16 minus 28 over 4. Oh,
87 over 4.
Thank you very much. Okay. All right. So very good. Now, second one. We have, if R is the reason, once again, bounded above, right? Bounded above. Ha. Ha. Bounded above by, let me just using f of x equal to 9 minus x over 2 squared, and below by g over x equal to 6 minus x, right? Find the area region R. Okay, so we know which one is the top curve, which one is the bottom curve, right? So we have to draw this one. So roughly, let us do that. And parabola up and downwards, and then straight line, negative slope, right? So you 6 minus x, which will be like this. Y-intercept 6. Huh, no. Hold on. Okay. So this will be f of x, and this will be g of x. All right. So we want to find the area between here. Did I say between there, the two? Okay. Yeah, I did not say that here. So 1 to 4, 2, 4. So all right. So in this case, they don't give us the interval, right? Where to where we have to integrate. Where to where we want to find the area, right? Then, does anyone has an idea?
Oh yeah, you make each side of the equation equal, like 9 minus x squared to the second equals 6 minus x, and you like
Very good. Yeah. So,
x by itself.
So we want to find, basically, we want to find the intersecting point here, right? Then how did we from the algebra course, right? So intersecting point, we set two equations equal to each other, right? So we're gonna do that. So 9 minus x squared over 4, I wanna say it like that, equal to 6 minus x, okay? Now solve for x. Okay, now since we have a quadratic, we move to the everything one side. So plus 6, so negative 6. Let me do everything one step. How about move to the right side? Because the x squared has the negative. So we have 0, 6 minus x plus x squared over 4, negative 3. I'm sorry, negative 9. Yeah, okay. Now then we have 0 equal to, we have x squared over 4 minus x, negative 9 plus 6.
Negative 3.
Negative 3, right? But we have a fraction, we don't want that, so we can multiply by 4. So we have x squared minus 4x minus 12 equal to 0. Now, can you factor out?
Yeah, x minus 6 and x plus 2.
Thank you so much. Let's check that. Minus 6x and plus 2x, which is negative 4x. Very good. Now, by zero product property, we have x minus 6 equal to 0. So x equal to 6, x plus 2 equal to 0. So we have x equal to negative 2, right? So look, this will be x negative 2. And then this will be x equal to 6. Okay, now we know the top one is the parabola open downwards, which is f of x, and then they say so above bounded above by, right? So let us set it up. I need a function, so let me see. From -2 to 6, top, which is 9 minus, let me write down this way, minus the linear, which is 6 minus x, and then everything dx. Okay. This is too close. I want to make it like that. A little bit nicer. Okay. Let us simplify -2 to 6. Let us do -x squared over 4. And negative is positive x. And 9 minus 6. We
3.
had earlier. 3, good. Okay, now we integrate. So we integrate the first term, what do we have?
Make it as 3 over 12.
Excellent, plus second term.
1/2
Excellent.
s squared
Very good, third term.
es.
Excellent. So we do evaluate from -2 to 6. Now, please, I need your help. Okay. -6 to the third power over 12 plus 6 to the second power over 2 plus 3 times 6 and minus, it's a negative, right? And then another negative there. Oh, confusing. And another negative.
Professor Lee, why 12? It's I know that 3, but it's not 5. I'm just confused on the 12.
This 12, you meant?
Yes.
Okay, this 12 will come from so we have a -x to the third power 4 times 3.
Oh, it's time. Okay. Okay.
Okay. All right. That's 12. Okay. Please check the negative sign. Too many negative sign there. Plus -2 squared over 2 plus 3 times -2. Oh my God. So sorry. No space. So forgive me. Plus 3 times -2. Okay. All right. So first term, what do you have?
And just 18 minus 18.
Minus 18?
I got that too.
Oh, wow. Good job. Oh, nice. What about second term?
Plus 3 plus 18. So 18 is withdrawing.
Plus 18.
Plus 18? Oh, you mean the first term. Okay.
Oh, it's 8 minus 18
It's 18.
plus 18. The second term is also 18.
I have a-
The-
I have 18. So can you please give it to me decimal if you took right about the dealing with the fraction, okay? You wanna go with the yeah? Okay, let's do it together then. This is the hardest part, right? So 6 to the third power. Six to the third power,
216
216. So we have
divided by 12
12.
is
and plus 2 squared, which is 36 over 2, plus 18 minus, okay, negative 2 to the third power is 8, negative 8 and positive. So it's 8 over 12. And negative 2 squared, which is positive 4, positive 4 minus 4 over 2. And the last term, which is negative 6, but positive, but negative 6, correct? Now, 216 divided by 12, we get the negative 18 you set up, plus, and 36 divided by 2, which is, you say that positive 18, right? And then third one is also positive 18, and 8, 4 over, no,
2 over 3.
so 2 over
3.
3, good.
3
And then this one is
plus
just
2
2.
plus 6, yeah.
minus
Maybe
6.
plus 6.
It's
Plus
positive,
6?
right?
Plus 6.
Thank you, plus
Positive.
6. Thank you so much, because negative, right? Good. All right, so please correct me if I make a mistake. So this is 0, and 18 plus 6, which is 24, minus 2/3, minus 2, 24 minus 2, which is 22, minus 2/3. We get 28 over 3, 30, I'm sorry. So let us make that.
64.
So which is 66
64.
minus 2 over 3. What do you get?
64.
64 over 3. Is it correct with the book?
It's 21.3.
Yes. So we got it, right?
Yes.
Okay, good. We got that. Good job. Thank you very much. All right. The calculation is the hardest one. All right. So now, let's do this one. Find the area what is the reason? Between functions f of x equal to sin x and show x equal to cosine x over the interval 0 to 0 to pi. Find the area of region R. Okay, this one, I want to bring the screenshot here. So I should make a little bit nicer. Screen, which one? This one. Oh, I have this one. Oh, I wanted to give it to you a tip for this one. Yeah. So I got this one from Desmos. If there is no interval where we want to integrate, right? Then, I mean, before we had in person, then everything is paperwork, right? Then you have to using by hand to find the intersecting point, right? But then these days we're using just technology, everything, right? So why we don't get the benefit, right? Oops. So, peace. Okay, good. We can find the Desmos intersecting point easily, right? I mean, your hand is faster than Desmos, that's fine, okay? Some problem is easy, right? Rather than is typed there, right? So I showed it here. So Desmos gives you the intersecting point nicely, right? So we can use -2. And +6. All right. Okay, now let us do this one. Okay, I want to bring this one to screen. So I want to, I wanted to save the time, so I prepare already. Okay, now the black one is here is sine x because sine starts at 0, right? And cosine x is the red in this case because it starts 1, right? All right, then we want to find, let's see. We read, we want to know about the area between 0 to pi, but this interval, it's about the x interval, right? X-axis. So I cannot type there in Desmos. So I have to type because it's 0, 0 and pi, if x is the pi, then y value is 0, right? So I have to type this way, all right? Now, look, from 0 to pi, we want to know about the area like this. So like that, and like this. Pi, first pi. Okay? Now, then we say that we want to find the area between two curves. There must be top minus the bottom. Okay? Now, can you see that from 0 to here? Then top is the cosine x. The red one is cosine x, right? The bottom is black, which is sine x, right? After that, here the black one, which is sine x, is the top, and then red one is the bottom. Yeah, so we're gonna split the two parts in this case. So let us do this. So reason 1, reason 2, let's see. So this point will be pi over 4. Okay, so we split to two reasons. Okay. From 0 to pi over 4 and pi over 4 to pi. Okay, now top minus bottom, which is red minus black, what I said earlier, the red was cosine, then black was the sine, and after pi over 4, black is the top, so it will be sine, and bottom is the red, which is the cosine. Okay, now what's derivative of I'm teaching calculus 1 this one. What's the antiderivative of cosine? Oh my goodness.
Sine.
Sine, good. So we have a sine. What's the antiderivative of sine?
Negative cosine.
Negative cosine.
Negative cosine, but we have a negative there, right?
Positive. Yeah.
Plus
Yeah.
cosine.
Positive, good. Okay, and then we evaluate from 0 to pi over 4. All right, now antiderivative of sine x.
Negative cosine s.
So we have a negative cosine x and antiderivative of cosine x,
Sine s.
sine x. Well, we have a
Negative.
right? Good. So we have a negative, so it's a sine x. Excellent. So pi over 4 and 2 pi, pi, right? Okay. Sine pi over 4 plus cosine pi over 4 minus sine 0 plus cosine 0 plus negative cosine pi minus sine pi, sorry, no space, and negative cosine pi minus sine, I'm sorry, pi over 4. Crazy. Okay. All right. Sine pi over 4, what do you have?
Square root
Uh,
2 over 2.
So
Very good. And cosine pi over 4?
same.
Square
three.
root 2 over 2.
Thank you so much. And sine 0?
0.
0. Cosine 0?
1.
1, but we have a negative 1, right? Good. Okay, plus cosine pi,
Negative 1.
1.
negative 1, but we have a negative sign, so positive 1. And sine pi,
0.
0.
oh, good. But negative, but positive is the same. Okay, cosine pi over 4, we have square root to 2 over 2, but it's negative, positive, right? So it's a positive. All right, we have a negative, also positive, square root to 2 over 2, right? Okay, this is 0. 1, 2, 3, 4, 4 of square root to 2 over 2, right? So we simplify, good. So we get 2 square root to 2. Excellent, good job. Easy, huh? Very good. Okay, now. What number for this one? Example number 4. Okay. consider the reason in figure 2.7. So the figure will be given. Find the area of R. Okay, so I want to bring screenshot. Oops, click so fast. This one, the last one. Copy. And then I'm gonna use it later again. This one. Okay, this reason was not clear like earlier one. Yeah, earlier one, we can obviously see top minus bottom, right? Okay, then this one also, reason is not clear, not like area, like between the area, the area between area between curves was not clear, right? What we do in this reason, okay? I want to split, look, if we split this way, something not using, split, then we can use area number 1, area number 2, we add them, then we can find the area, all right? And then can you see that area of number 1? We have just one curve there. So it's basically like calculus 1. We need to find the area under the curve, right? So under the curve, area 1 has only parabola, right? Area 2 under the curve, which is just a straight line. Yeah. So let us do that. So this area 1. Oh, we're gonna find the area, right? So I should not use that. That's area 2, which is area, right? Okay, now we do look from 0 to 1, right? And then I said it's just a parabola, so we will have x squared dx plus from 1 to 2. So we have just a straight line, so that is 2 minus x is there. Actually, 2 minus x there. So 2 minus x. Okay, now x squared, what do you have?
X to the third divided by 3.
Very good. And then we do evaluate from 0 to 1. Now, we antiderivative 2, what do you have?
2x.
2x
X, good. And minus x, we,
to the second divided by 2.
okay, x the second power over 2, very good. From 1 to 2. Okay, now 1 over 3, or we can just factor out, right? So 1/3. 1 minus 0 plus we have 2 times 2 minus 2 square over 2 minus again 2 over 1/2, right? Okay. Now, the first one, I can do it. Second one, you do it. I did one, you do the second one.
Nice deal.
This is fair. Hmm. So what do you have? So 4.
One half.
This
Oh,
one half?
wait, 1 divided by 2.
Uh-huh, 1/2?
I hope
Oh.
so.
Yeah, someone agree? Confirm? Yes?
Yes.
Okay. Mm-hmm. Now we do the 6. So 2 plus 3, which is 5 over 6. Good. Thank you. Good job. All right. So far so good, right? Now we did the reason defined with respect to x earlier, right? So everything is x value, right? Now we're gonna do respect to y. So look, let me write down the definition first. Theorem. Two 2.3. So we have, let me write down. Finding the area between two curves. Integrating along the y-axis. Okay, so in this case, we have so we denote this one like this: u of y greater than v of y. Then they have area, means that area, right? Equal to integral from c to d, and then they make absolute value. U of y minus the v of y dy. Okay. All right. So let us do this one. I want to bring the picture. I want to bring back this picture. Okay, so look, we did earlier. We integrate the respect to x, then we divide the reason, right? This way. And then we found the area here and there. We add, and we get the total area, right? But if we are using the definition, integrate along the respect to y, right? Then look, this means think about right curve minus the left curve. Okay, so like a top curve minus bottom curve. then we get the area, right? Then right minus left, then we get the area between two curves, okay? So in this case, look, the straight line will be right? And then this parabola will be left, right? Then right minus left, then we get the area between two curves, okay? All right, then everything we're gonna change it in terms of y. So let's see. We have, let's see, y. Let's say that let y equal to x squared and solve for x. How do you solve?
You have square root both sides.
Square root of both sides. So yes, good. So we say the plus minus other side, but then in this case, we need the above, right? So we take the only positive. So we have positive square root of y equal to x, right? Now we have y equal to 2 minus x, solve for x again. So what do we have?
Y plus 2.
Y 2 minus
It's actually
y, right?
better to just also transfer the minus out of x.
Yeah, so 2
So
minus
it will be 2 minus y, yeah.
Very good. Now the right, which is the straight line 2 minus y, right? So we're gonna do that. The reason, let's take the reason. We are looking at the region in terms of y. So y interval, we're gonna see that. So from 0 to 1, okay? Instead of 0 to there before, okay? We split it 0 to 1, 1 to 2, right? So we do that 0 to 1. So 0 to 1. Now 2 minus y minus square root over y dx, dy, sorry. Okay, we have 3 terms. We integrate term by term. So 2, what do you get? Integrate
2x.
2y. And minus y.
Y square over 2.
Very good.
You
Now, power y to the 1 over 2 power.
just y.
2 over 3. Oh,
But let's just look that y is like
Okay, be careful. We do it antiderivative.
yeah.
Yeah. So 3 over 2 then, 2/3. Good. So from 0 to 1, I know, so confusing all the time. So 2, 1 minus 1/2 minus 2/3 times 1 minus, oh, lucky, 0. Whew. So what do you get? So let's see. 6, 12 minus 3 minus 4.
7 over 6.
5 over 6.
5 over
5 over
6.
6? Okay. Okay, very good job. Okay. I explained to you, right? I explained to you. In this case, much better. We do right side, right minus that, then we get this result. Okay. Oh, y is y squared over 2. Let's see. Oh, not that one. Oh, here we enter derivative. We add the power and divide by new power. Yes. Okay. All right. Thank you for coming. And we finish early because you guys helped me a lot.
Miss Lee, can you scroll it up all the way to the beginning, the first.
Sure. Thank
Thank
you.